Welcome. Today's lesson is on ellipses or ovals. Now, ellipses do have a center, which is right in the middle, that they call the center. So the center for this one would be 50, the point 50. They also have what's called a major axis, which is the longest distance that's inside the ellipse. They have a minor axis, which is the shortest distance inside the ellipse between two opposite sides. And then they have what's called the vertices, which are the endpoints of the major axis. So the vertices of this ellipse would be the point 5 is the one vertice. The other vertice would be the point 5, -5. And then on the minor axis, it has co-vertices, and those are always the endpoints of the minor axis. The co-vertices would be 8, 0, and 2, 0. Now, they will often also talk about the length of the minor and major axis. So the major axis obviously has a length of 10 units. The minor axis has a length of 6 units. And remember, the major axis will always be longer than the minor axis. This question here asked us to define what are the co-vertices. Co-vertices are the endpoints of the minor axis. So what I would actually plug in is these 2 points here at 2, 0 and 8, 0. And again, you're going to be asked very similar questions to that in Prollies. What is the center? Well, that one's hopefully easy. It even marks it for you. The center is 0, -5. So hopefully centers will be a pretty obvious thing. What are its vertices? Now be careful. The vertices are the endpoints of the major axis. That's the longest distance. So that will be this one here. So the vertices would be this point here and this point here. Up and down would be your minor axis and your co-vertice. So we're going to plug in the -7, 7 for the one vertice and 7, 7 for the other vertice. And what's the center? Center is 0, 2. What is the vertices? I'm going to skip ahead. What are the vertices? So now let's talk about the equation for the ellipses. Now the equations for the ellipses look very similar to equations for circles, except the one difference is it's always equal to 1. It's not equal to the radius squared because ellipses don't have a constant radius. It's equal to 1. And then the x minus the h, which is the center's position, squared, is over what's called either a squared or b squared. And then we have the y minus the vertical position of the center of the ellipse, in parentheses squared, over b squared or a squared. Now the difference between a and b is a is always the half the distance of the major axis. B is half the distance of the minor axis. So if the larger number is under the x squared, that tells you it's going to be longer horizontally than it is vertically. If the larger number is under the y squared term, then it's going to be longer vertically than horizontally. So right here, this one, it's just asking for the center. It's asking for the value of h and k. But since there's no parentheses, the center of this one is actually the origin. It's 0, 0. So I'm just going to type in 0, 0, and then we'll look at the next one. Okay. Ooh, I lost some of my equation. Now it's back. So again, here, another center one. Again, very simply 0, 0, because there is no shift in the x or the y. There's no h or k value. I lost that again. Now it's back. Now this one does have a shift in the center, right? Because the center has been shifted the opposite of what you see. It's been shifted 8 units up, but the horizontal shift is still 0. So I have a center of 0, positive 8. I'm going to quit putting that in. Just remember that's always over a squared. I don't know why that keeps disappearing. It's really irritating that it keeps disappearing. Okay, so now this one here, though, we are looking for, again, the center. So maybe I'm going to skip forward because the center, again, is always the h and the k value, which for this one it's 0, 4. All right, now it's asking for the co-vertices. So let's talk about the co-vertices. The first thing I want to emphasize with the co-vertices is the co-vertices are going to be the square root of the smaller number added and subtracted from the center. So the very first thing you're going to do is you're going to write off on one side what the center is. So the center is 0, 0 for this one. There's no shift in the ellipse. The next thing you're going to do is, if it's asking for the co-vertice, you're going to take the smaller number, which happens to be under the x. Since it's under the x, that means your ellipse is longer vertically than it is horizontally, and we're looking for the two co-vertices, which are a distance away from the center. Center is 0, 0. So what you do is you take this number that's under the x squared, which is this equation down here, which is b squared. We're going to square root 4. Square root 4. That gives us a length of 2 that I need to move to the right and left of the center. So again, my co-vertices, if the center was 0, 0 and I move 2 to the left, it's going to be a negative 2, 0. And if I move to the right, it's going to be a 2, 0. Will be your co-vertices. Okay, so now here, what are the vertices? Now the vertices are going to be the distance above and below the center because the larger number is under the y squared. We still have a center of 0, 0, but now I need to go up and down whatever the square root of that number underneath the y is, the y squared, because that's the larger number. Square root of 100 is 10. Center is 0, 0, so my vertices will be up 10 and down 10. So 0, negative 10 will be the one vertice, and 0, positive 10 will be the other vertice. What are the vertices of this ellipse? Again, 64 is larger than 25, so we're going to be up and down from our center. Our center is still 0, 0, and the square root of 64 is 8. So I'm going to be at 0, negative 8, and 0, 8 for my vertices. Okay, co-vertices. Co-vertices are the smaller of the two numbers. So 39 is bigger than 36. So now my co-vertices are going to be are above and below the center, because the y squared, this is open longer than it is open wider than it is tall. But take the smaller number, square root it, that's 6, and I'm going to add 6 to the y because that's the number above it. So I'm going to have a 0, negative 6 as one co-vertice and 0, positive 6 because the center was 0, 0. All right, so I'm going to skip this one. I'm going to jump ahead, see if we get, okay, so what is the center of this ellipse? Well, that should be fairly simple because we have the, in standard form, where we have, and actually that is the a squared underneath the x because the 64 is larger. This is smaller, so this ellipse is open longer, but it's just asking for the center. So the center is just the opposite of what you see here and here. So your center will be positive 9, negative 10. What are the vertices? Now we got to be careful because the center is not 0, 0. The center is 2, 4. The vertices are going to be the distance above, let's see, not above and below. This is a larger number, okay? Oh, and they want you to leave it in rational form. So square root of 70 does not reduce. So what you would end up doing is if it's above and below this center, your x value is always going to be this 2 now, but now you're going to be 2, and now you're going to be 4 minus the square root of 70. And then you're going to be 2 and 4 plus the square root of 70, because that is the distance up and down from your vertice. What are the co-vertices? Okay, that will be nice. Co-vertices, 4 is smaller than 48, so we're going to square root 4. That's 2, and it's below the x, so we're going to add and subtract 2 from the center. What's the center? The center is, again, I'm looking right here to find the center. Getting too much here, but the center is 4, 6, and I'm looking for the co-vertices, so I'm going to move to the right and left of 4, 6. So if I move to the right or left, the square root of 4, which is 2, I'm going to be at 4 minus 2 is 2, 6, and then 4 plus 2 is 6, 6. I'm going to clear all this out because this is getting, there we go. So what are the co-vertices? Co-vertices, again, smaller numbers 92. The center is 7, 2. And the co-vertices are left and right of the center because it's below the x value. So the y value will not change. The y value is 2. So I'm just going to quickly plug in 2 here. 2 and 2. And then I need to figure out what the square root of 92 is. I'm not sure if that can be reduced at all. 2 goes into 92, 40, which leaves 12, 46 times. So that means 4 goes into it. So that's 4 times 23. So square root of 4 and 23, I can square root the 4 to a 2. So the reduced, the rationalized form and simplified, it's going to be 2 square roots of 23 that I'm going to add and subtract to the x value. So that first x value will be 7 minus 2 square roots of 23. And the other x value will be 7 plus 2 square roots of 3. Again, if you have any questions on how to do this, please bring them to class. Let's see, isn't that what I did? 7 minus 2 square roots of 23 and 2. Sorry, the correct is, yeah, 7 plus 2 square roots of 23 and 2. What did I put? 7 plus 2. Oh, I dropped the 2 right there. See where I made my mistake? So I did actually do it all right. It's just I put a 3 underneath that square root and not a 23. So I did do it correctly. I just didn't watch myself as I plugged it in. So be careful when you do that.